sort of like a light pollution.
Here, you need a pointer. Sure. You going to explain what that is?
Yep,
Okay, what is that?
that's the Rosette Nebula. And what I'm going to cover tonight is how I process my images, and just show y'all what I do. Of course, like I said, because we kind of went over it a little bit last meeting, just to show everybody. Well, after I've taken the image off the camera, this is generally what they look like.
Wow.
And then you come in and you stretch, I will cover it in detail, but, after processing, this is what I get out of it.
Briefly, how do you get there?
Well, that's what it's all about.
Oh, okay, gotcha.
Of course, I brought the camera last time, and the camera came with Artemis, which is the capture program. I use my red, green, blue filters to take images, and there goes the projector.
Keep talking, it's okay.
Yeah.
You got it on this screen?
Yeah.
Okay.
We can do that.
I guess we can turn the lights back on this. I don't think, well,
No, I think we're better off.
What is it, a heat problem for the
Yeah.
projector?
yeah, they didn't do that last time.
It made that lamp maybe can ring a bell.
Maybe. I use my filters, I'll set the Artemis software up, and it'll grab X number of red, X number, then I go out and change filters, line it up, X number of green.
How many seconds on each one?
It varies, because I'll take a test image and stretch it out and see what I've got. Sometimes I go from as little as 5 minutes, all the way up to some of them I've done 10, 20 minutes.
How long does it take before you start having trailing and stuff like that?
That's what the mountain guiding takes care of. I don't have to worry about that.
Oh, so you got a guide scope on it? I mean, a guide scope and a camera? Okay.
All right, after I gather my image, I sit down with first I use Deep Sky Stacker to stack and clean up the images, which I'll cover that here in a minute.
What are you using stack, you said?
Deep Sky Stacker.
Okay, what scope are you using this on?
This is my 80 right now.
Your 80?
Yeah,
Okay.
short tube 80.
Okay.
Mhm.
Is that a Orion? Okay.
Let's see, what was
Is
I
that
at?
Aquaman or Acroman?
That's
I think it's an Acroman.
it's Acroman, yeah.
Aquaman.
It's not even an ED.
Okay, gotcha.
Um,
Hate to interrupt, but if I don't get it now, I won't. It'll be way past me.
I'm trying to remember where I was at now.
It's okay.
Was time consuming, he was there, so don't, it's your last sentence there.
Yeah.
Even with a guide scope, isn't there a limit? Don't you eventually get to the point where there's an apparent rotation?
If you're using Alt-Az, you do, but with equatorial mount, which I use, you don't. That's the whole point of the equatorial mount. It gets rid of the star trail, because you're actually following the path of the stars.
Okay, so what mount are you using? Are you just putting a wedge under it, or? Are you
No, I've got a CG5,
Okay,
CG5 GT,
okay.
or ESGT, whatever. Yeah, okay.
One more thing, what field of view are you looking at with that generally? Is that prime focus, or is that through a,
It's prime focus. I'll have to look
you know what the field of view is?
I'll have to look it up.
Okay. And how do you calculate that field of view?
I'll let Stellarium do it for me.
Good answer.
Let's see. With a short tube 80, I got a 1 by 2 degree, well, almost a 2 by 2.5 degree field.
Okay.
And that's a 15, right? I mean, by itself, it's 15 power.
That's an F what?
It's F5.
F5 focal region. Now, if you go up, say a 6, it'll cut the field of view down. If you go lower, it expands field of view, right?
Yeah. Yeah. Okay.
Faster and slower.
Back to. Okay. Okay, yeah.
In a few minutes, we could have that hooked up. Yeah.
Okay, now, all right, yeah. I've done totally lost my track of thought.
You thought about you using your red, green, blue, red, blue, and green
Yeah.
to check every 2 images.
Yeah, okay, yeah, and that's where, usually, if you have a filter wheel, you can change filter wheel, you can change filter without changing the orientation of the camera. I don't have a filter wheel. So, I would have to, normally, you would have to take your stacked images and line them up manually, and then stack them. But luckily, there's a Deep Sky Stacker that does that for me. So, to do it, I use reference stacking, which is I pick the image I think out of that stack that best centers the object I want, and I use that one image, like I might pick the red and say, okay, that's where I want the object to come in the field of view, and I want all the rest of the images to be based off this one, so I will stack them out using one of those images as a reference frame.
Okay.
And then it will stack and line all the images up and put me on, it'll make a red image.
It uses that as a, you say reference frame or model,
Mhm.
and then it just stacks it.
Yeah.
Is the Deep Sky Stacker, is it freeware or?
Everything I use is free. I don't use any paid software. Unless even my guiding solution is free. Share doesn't.
Can you have the capability of writing it yourself if you need to?
No, I'm not that advanced with programming.
Okay.
Let's see. Okay. Okay, yeah, right here I'm talking about how I'm using Deep Sky Stacker to, using that reference frame, it lines all my red, my green, and blue frame up. So that way, when I go to my image editing software, they're aligned up properly. And let's see, and I actually go through how I do it. Of course, oops, back up. And then it's basically, I put my stack images in. I've got the one I've chosen, like in this instance, it shows my red images. I really wish this was on the big screen. Let's see. That's not going to do it. Okay, there it goes. That didn't make a difference. And I've got my green as my reference. So that means it's going to take all these reds, and wherever the green is centered at, it's going to get the reds in that area. And then, basically, I tell it to run through it.
How many images you stacking then, does it say?
Oh, I'm just stacking 5 right here for the Rosetta.
That's only 5 images stacked. 5?
Well, that's 5 for red.
Oh, okay. So how many frames?
It'd be 5 for each, of 15 total.
And how long was exposure each one?
These I believe were 5-minute exposures.
Quite a while.
That is a long time. So
25.
And then here's where I select the intersection mode, which takes tells DSS I want wherever these images match up at, that's the part I want. So it not only does it stack the images up to help clean up, align and stack the images up to help clean up the noise in them, it also says, okay, now I'm going to take and trim off anything that doesn't show up in the reference image. So that way when I put them in image editing program, they're all the same, well, they're all the same size, but they're all same orientation and same field of view, so to speak.
What was your location when you took these?
Out there at my house, Casting Springs.
Is it dark out there?
Not bad.
it's past,
Just a little bit past 4.
Because the comparable's the same as the sports guys, right?
It's a little darker.
A little darker.
I got more trees around me, except for when the neighbor fires up their stupid lights in there.
If they know he's out there, a lot of times they'll turn them off.
When you threatened to burn his house down?
No, he just got to where he turns them off for me.
Well, Ben used to
Well,
fuss
yeah,
a little bit.
I fussed about it once, twice.
He-
Not,
I know
not,
he-
not to them, just out in the yard fussing about it. I guess they heard me.
Yeah, because he'd be out on the porch smoking a cigarette and he'd hear Ben fussing. Because, when you get mad, you get mad.
Astronomy colors are frequently false color. you're just using filters in a very natural sort of way. Is this in some sense then true color?
It's as close to true color as a CCD camera can get. Because, really what you're doing is you're filtering out, with the red filter, you're filtering out anything except for red wavelengths.
Right.
And the CCD isn't actually, it's just brightness. So it's the brightness of the red wavelengths that hit it, and the blue and the green to unfiltered. So, and it's only true as much as the processing of it. See, a lot of it comes down to the fact that when you process the image, not every, because of sensitivity in the chip and the atmosphere and all the variables involved, that particular night, red wavelength might get through better. But then you turn around 5 minutes later, you run your greens through, or an hour later, you run your greens through.
Yeah, but
Very
you're still
different
mapping
part of
red to red, blue to blue,
Yeah.
green to green.
Yeah.
Like I think what Alan's talking about, like for the Hubble images, a lot of times they map hydrogen alpha to red, sulfur
Yeah, that's what I
to
was
sulfur
Okay, yeah, okay.
to green, and O3
Yeah.
to blue.
Yeah, which is why their images look like they do.
Right, but like I said, that's false color that
Yeah.
you use.
Yeah, I'm actually doing visible light.
The human eye requires a lot of light to perceive color. We can perceive light and tell that there's a light there, but to see the color, you need a lot more light. So I guess what I'm asking is, if you had a big enough honking objective, would you see that Rosetta in about the same color that you pictured here?
I doubt it. Because you got to think how, even in big telescopes, the Orion image still looks bluish.
Isn't that remnants of supernova? Okay, and that mostly hydrogen
No, most of it like should be H2.
is blowing out?
Yeah,
So what color are you gonna get off hydrogen?
red.
Okay, then that's,
Yeah.
it's not red.
I think it would be pretty close because I mean he's mapping the colors to their true colors. So it's not like he's mapping O3 to green or something. So.
Unless he's biasing a lot more of one color than another.
Yeah.
Which, that's the, that's where you get into the filters themselves, sensitivity on the CCD.
Now, is the video cam about the same process? This is a CCD camera, right? It's not a video camera.
Yeah, it's a CCD camera. You're not going to be following this process with that.
No.
Not exactly. You're going to be using a different
Forget
software.
it when you run here.
Well, no, but, yeah, but I do have a question on that.
Okay. Now, as you can see, this is showing it actually.
It's rendering it, right?
Yeah, as the process is going through, it's right here, it's telling me what it's fixing to do with it. It's going to align it, it's going to use, it's going to align the red, green, and blue channels, which is kind of silly because there aren't any. And it'll go through each one of these steps, and then at the end, like, here's the output. That's that first image I showed you. And then, of course, I save one out for, one of these for red, one of these for green, one of these for blue, and you can see where the image data is the spike right there.
Is that your modeling images that you've got over there? The ones you saved down?
Mm-hmm.
Okay.
Just, do you 24 frames a second, or do you know how many frames a second you're doing?
That's not
Okay.
video.
Oh,
No, he's not a video.
Yeah, it's one shot monochrome.
One shot.
So it's a solid. It opens the shutter for 5 minutes.
5
Stays
minutes.
Yeah.
there. Yeah.
It's not shots per second, it's
Yeah.
5 minutes per shot.
Yeah. It's a camera.
The video, but see, the catch with, well, we'll cover that after. I'll get back on that.
Because I didn't realize a camera could stay that, on the CCD could stay up for that long.
Yeah.
Yeah. Oh yeah. Even your DSLRs can.
Go time
Yeah.
close.
Okay.
Bulb mode. But basically, my camera runs in bulb mode all the time.
Heating problems.
But that's where mine comes in. That's where the camera.
I've got that cooling.
Yeah, the whole back of the camera's got a cooling system.
Yeah.
And you can also process that out.
Yeah. With
With the dark, you take a dark frame and you can process out that what they call amp flow.
Okay, let's see. Now, Okay,
I
this.
guess that's what threw me off, because you was talking about, you was talking about a stacker, and usually a stacker is for images, but the only reason you're using a stacker is just for the colors. Okay.
No, it's stacking is in.
No, what the a stacker program in general, with astrophotography, what it's doing is it's taking multiple images and saying, okay, in this image, this pixel and this pixel are the same, I'm keeping them. This pixel and this pixel, okay, I don't know, they're different.
Yeah.
So I look at the next image and say, okay, and then pick, that's all I'm doing.
He's still just increasing the signal to noise ratio.
Yeah. Yeah. So I'm using it to align, increase the signal to noise ratio, and crop the images. Is what the DSS does. Okay, now, and of course I'm saving it. Now, I use my actual image editing process program is called GIMP. Now, if you ever go to download it, there's a catch. The current release that everybody gets from their main website doesn't support the 8-bit images. And that's horrible for astrophotography because you don't have the dynamic range that an astrophotographer needs. Because I don't know, on that chart where you seen that little spike, that whole bar is the image. That little spike's my picture. I've got to get rid of all that stuff around it. So that this default GIMP doesn't have the range to spread that little bit of data out. But that's where there is a development version out right now, version 2.9, which will eventually be version 3 when it's released public. And I've got a link here if you ever wanted to go get it, that I use, that takes care of that. It actually gives you 256 colors on each image. And having said that, let's see, well, what did it do?
Your numb watch don't want, so they go to sleep. No, what is that other line over there? That's your numb line?
Yeah, it's my unlock.
It didn't go off either, it's your cap
There
light.
it goes. I want to sleep.
Okay.
Again, I want me to go to sleep. Okay. Oh. Or it decided to reboot.
Upgrade the windows.
Thank you.
I hate when that happens, you're right in the middle of something, oh, update.
Okay. Let me spin this for a second.
No.
Thank you, Microsoft.
I read somewhere one time, computers is the only thing that our society has accepted that every once in a while you have to shut down for a little while and turn back on. Because can you imagine if you're driving down the road every once in a while and your car stopped working, you had to pull over the side of the road, turn it off for a few minutes, turn it back on? Nobody would accept that.
True. Or they get fined $1.2 billion if it just turns itself off.
Yeah, there you go.
But in society, computers are the only thing that we've accepted and that's just normal.
Where's that money go? When they find
I guess
somebody?
the government gets it.
I know they get it, but what do they do with it?
What do they do with the rest of the money they get?
I'm sure they apply it toward our name on that, don't they? That insanity.
All right.
Good Lord, how much stuff's done on your desktop, man?
Where's the slide?
Because I mean, you use your desktop.
The Geek Squad come out.
Like
and fix
everything
that
on,
thing up.
everything on his computer, but his desktop, it looks like. I'm one of the kind of people I like to keep my desktop minimal.
I hate hunting for stuff.
What's the Goldie agent? What's that?
But it's an inside joke for the developers of the game.
Okay.
The new image technology that they're using, there's a the developers of it, it's the GOAT project. So GIMP has been invaded by the GOAT project, so it's the GOAT invasion.
But it's freeware,
Yeah.
and that's why we're not looking at Linux right now, right? You run Linux too?
I did for a while. I've been wanting to get a laptop or computer out in my observatory running Astra Linux. But if they ever get version 2.9 GIMP on it, I will. Let's see.
It's like a Ubuntu or is it a Linux?
I think it's based on
Has Linux
SUSE.
pretty much replaced Unix?
I don't know.
Maybe just for, on an amateur basis.
Well, no, there's a lot of professional systems that use it. Well, I mean, every Android phone uses it.
Hmm.
Basically, well, IBM uses it, and just about everything that they used to use Unix in. It's just some people have written so much code for their specific Unix, they stuck with it, and everybody else is switching to Linux. I mean, even our mainframe at the Department of Labor
I
runs
didn't realize
Linux
there's a
now.
correlation between the two. So,
All right, let's see.
never thought of it.
Okay, now let's get this done up. And where are we at here? Of course, now I was better prepared last time, but we had so much business, we didn't get to do it. Oh, there we go. I'm going to show what I usually do. Let's see. What I will do in here is I select my color layers and I open them up. Of course, it's not open properly. This is why it's a development version. You get these crazy error messages that normally wouldn't show up. Okay. Right, let's see, that's my red. Green. Okay. Now I've got my layers here. Alright, I'm going to take the red layer, for example, and I will add first thing I need to do is put the thing in color mode.
How much is it for? Or two, was it $2.99?
Let me hide these. And we'll change the mode so that it applies the color to the layer behind it. And I'm going to merge these two layers. We'll combine my red with the red background I just made. And then when I come over here and go to my color levels, I can actually bring that image out. Because you just see it right there. And then it's
He was changing the histogram.
for it to process. Let's see, I trimmed all that data out and there's still, so I'm gonna bring, this is my dark slider side of it, so I'm gonna move my black up to just shy of the edge of that right there. And then I'm gonna move my white slider back this way, so that way I can bring, and I would just do each color like that. Because see, you can see the stars are all just red dots. And I know we got time, I was gonna just go ahead and do it.
Fascinating to me to stop to think about what an amateur can do now compared with what it would take a professional to have done 10 years ago.
Yeah, well, that's like, I wished I had brought it. The, I think it was Sky and Telescope, had an article comparing the first color image that was known to have been taken through a telescope versus a 1-second photo from an iPhone, and they're virtually the same image. I'm just gonna run through these. Oop. Okay.
I would definitely love to know how to do that and get, have it, that's stuff, well, of course, I had the telescope first and the camera and all that, but
Yeah, it just takes time and practice.
it looks a lot like, well, as far as the layout and the way that particular program works to the Finale program that my dad uses for his music editing. It's very intricate and got a bazillion different buttons that do a bazillion different things. And you can do all sorts of things, but of course, just learn what you need to use. All you use.
Oh, while you're going through that, maybe you want
Okay.
the, you ever thought, say, hey, should I get it done in 1 minute exposures? Would you get the same image, you think?
No, because you look, the fainter outer edges would not show up. You get the bright core of it, but your fainter details, fainter as in.
But you didn't come out, you kind of you did research and all that 5 minutes was kind of like the.
Yeah, like I said,
Sweet spot for
yeah.
that.
Yeah, I would, what I generally will do is I'll take a test image before I start my own. Like I'm a red filler, okay. I'll take an image and I'll stretch it. Okay, let me go a little bit more. Take an image. Because, the sky conditions vary. Because some nights I can go out and sky just won't take a 5-minute image. You end up, there's too much haze way up high, and you end up, your background.
Too much light, yeah.
JD, were you thinking of taking 1/5 as much time, but 5 times as many images, so you got the same total light?
That's what I was gonna ask.
Well, that's where I was at first when I thought we were stacking images.
But it is 1 5-minute exposure.
It's not direct.
Do you get more detail out of 1 5-minute exposure or 5 1-minute exposures? Or do you get the same detail out of both of those?
As long as you, see, that's where the rub comes. Because a CCD, well, any image chip is just a photon counter, and it takes X number of photons to hit it before it increments. If the fainter details, like take Andromeda for example.
Some of them just don't register.
Yeah.
So you'll get more of the fainter details out of 1 5-minute exposure than you will 5 1-minute
Yeah,
exposures.
and if you never in a 1 minute, the lighter outer edges may not ever
Trigger that
Yeah.
bucket, or
Yeah.
I call it bucket, but that detector.
And, but that's one of the tricks is that a lot of people use. You'll see these like Orion where you see all the detail way out away from it.
Right.
They've cheated some. Well, that's not really cheating. But what they've done is they've taken long exposure to get that. They've taken a medium exposure to get
The center.
the center, and then they'll take a short exposure to get. Yeah.
Oh, okay.
And see, even in that photo, the core's still blown out.
Right.
So you take a bunch of 1-second photos to get the trapeze in, but then you have to lay it over and cut out and add it as a layer, which I don't like doing because it's kind of fake to me. Let's see, layer. Let me just run through these real quick. That's another thing, I don't know if you remember from the red, there was a lump out here, and there was some back this way that's the green, you know, the way, the histogram's different, the spike's different, and so, you know, like you're talking about the color, true color versus, you know, that's where it's hard to explain, but that's where your variance in between, if you were outside the atmosphere and actually could see it, your variances in colors and versus, you know, the real color versus what it actually shows up as. Yeah, I remember when let's see. When I first started fooling with it, that's after being out all night, coming in and yeah, and then having to manually turn and align all the stars and stuff and figure out, you know, I'm glad I finally figured out how to get Deep Sky Stacker to do all that artwork for me. Let's see.
I did have a question about when you use the Deep Sky